Up on the board here, Beer's law. Does somebody know the formula for Beer's law? I'm sorry?
Concentration.
Concentration.
Times length.
Okay, absorbance is equal to
Concentration.
concentration. Okay,
Times length.
times length.
And epsilon. I forgot what.
Concentration times length. Length of what?
Of the cuvette.
Yeah, it's the path length of the cuvette. And so it depends on if you're using a 1 centimeter, 2 centimeter, 5 centimeter container for this. And so it's going to be concentration times length times epsilon. What is epsilon? Does anybody know what epsilon is? Epsilon depends. Yeah, epsilon depends on how effectively the substance absorbs photons. You know, and so a large epsilon, you're going to have a pretty high absorbance, a high probability transition, you know, electronic transition. A low epsilon is a less probable, you know, less intense absorbance. And so if we want the concentration from the absorbance, you can see absorbance and concentration is directly proportional because L and epsilon are constants. And so the only thing that's changing is the absorbance with concentration. And so if we're interested in the concentration, then we need to calculate a couple of things. For example, here, the concentration is going to equal the absorbance, which have no units. Sometimes people call them absorbance units, or AU, but they're dimensionless, divided by L and E. So we have the absorbance, right? We've got the absorbance here. The cuvettes that we used, what do you think the dimension of that was? 1 centimeter. Okay, so we'll go with 1 centimeter here. And that leaves us with epsilon. Epsilon you usually get from a Beer's law plot. And we didn't do a Beer's law plot. In a Beer's law plot, what do you do? What you do is you measure the absorbance for different concentrations. And so generally you get a standard solution and then you make a few dilutions. Do you guys remember doing this in red food color? Like a 10 to 100 dilution, a 10 to 25 dilution, a 50 to 100 dilution. And then you measure those absorbances, and when you measure the absorbances, the Beer's law plot comes out as a straight line, right? Where we have the absorbance versus the concentration, like this. And the slope of this is the length times epsilon. That's the slope. If the length is just 1, then the slope of this is epsilon. And so normally we would have to do a Beer's law plot in order to get the molar, what we call epsilon, which is called the molar adsorptivity or the extinction coefficient for crystal violet. But we didn't do a Beer's law plot, so we have two choices. We could just do the kinetics based on absorbance, which I've done many times in the past. Since absorbance and concentration are directly proportional, whatever happens to the absorbance is going to happen to the concentration. Or what we're going to do is we're going to try to find a more recent version of epsilon. And so I found two here that come up. One on Wikipedia, they give a extinction coefficient of 87,000 per mole per centimeter. See that? And then, you know, I clicked on this reference here. The references are important. You should have references in your paper. But there's something about this reference. Take a look at this reference. You see one thing that stands out? It's really old. I don't know if you can read that. It's hard to read, but the publication date is 1914. We take a look at this paper. Here it is, 1914. So that's pretty old. But that's, you know, that comes up in a number of things here. But there's something more recent. So I wasn't sure I was going to use this, but since I found this one, maybe we'll try this one instead. And the other one is here. That's 87,000. There's another epsilon of 112,000. But this came from 1987 data. So here's their data here, and they actually, this is good because they have the original data here that you can analyze and the extinction data here. So we'll just go ahead and use this one. And that way we'll just do it in concentration. That'll make the units make more sense. And so let's get the CB Excel template up. Yeah, I'm going to repeat the concept because we're going to use it. Except since we're going to use, you know what? Since we're going to use so you're going to type in your run 1 data. Now the times, you know, Excel does a nice thing with the times. We took times at what intervals? 0.2 of a minute, right?
Yeah.
And so let's do this. Our first time, we don't have a time at 0, do we? Do we have data at 0?
Yes, we do.
Okay, then type in 0 minutes here. But we don't want to put units because Excel doesn't like numbers and minutes mixed up. So let's put time and then we'll just insert the units minutes in the heading here. Can you guys see this okay? How about now? All right. There are two ways you can show the units. One, you put a slash there. Two, you put it in parentheses, like I did originally. The parentheses takes more space, and so that's less preferred, less desirable. The slash might take up less space, but people might get it confused by time divided by minutes, which doesn't make any sense. But that's the units there. All right, now the nice thing about Excel is you don't have to do a lot of repetition work and data entry. And so if we type in 0 and then 0.2, and then just highlight those two, then Excel will just repeat the pattern. Or extend it. So we go 0.2, and then we can go, how many minutes did we take for the first one?
20.
20 minutes. So we'll just drag it down until it hits 20 minutes. All right, so now we have our times entered in there, and we'll put everything to 1 decimal place. So we can do that using this little button up here on the bar. Do you see that? Just make it 1, and maybe we'll just center it here. So that's our time in minutes. Okay, now for the absorbance readings, you have to enter those manually because those change. So go ahead and punch in your absorbance. I'm going to use my okay, I'm going to use my made-up data, so your plots might not look anything like mine. Don't worry about that. I don't remember when that was. All right, I see a lot of, did a lot of you already enter the data in at home or something like that?
I haven't.
I'm going to go through this a couple of times, but let's write in our epsilon here. We're going to use the extinction, we'll call it the extinction coefficient. The extinction coefficient was 112,000.
Professor,
Yes.
can you scroll up a little bit so I can see what cell you're on?
Okay. I see. It's getting cut off from the TV. Like that?
Yes, thank you.
Yeah, you don't have to be on the same cell. It might help if you are. Extinction coefficient for the crystal violet was 112,000. This is going to be molars to the -1. Centimeter to the -1. And I put the units in a separate cell because I want the number alone. Like this. All right, let's put a little reference here for this. So I'm going to go back to that paper, take a quick look at that. Oregon Medical Laser Center. Ooh, I don't know. I wonder where the original data came from. This wasn't published in a peer review. That's probably why it's not on Wikipedia. Oh, here it is, Zollinger, 1987. Maybe it was published in peer review. Zollinger, 1987. There it is.
Make sure you copy it over the ABS with the absorbance.
We're going to put this at the bottom of the page.
Looking at the absorbance, it says on your list. At the top of the thing. But,
All right, now what are we going to do with the extinction coefficient? We're going to calculate the absorbance. Now, not calculate, I'm sorry, we're going to calculate the concentration, units of molarity. All right. Now, what we'll do here is we'll enter the equation. When you enter equation, you just, as you already know, since we already did the last lab, but it's equals. So the concentration equals what? It equals the absorbance divided by the path length of the cell, which is 1, so I'm not going to bother putting anything in there, divided by the extinction coefficient, which is going to be cell C5. Is that good? And so this is what I got. The concentration is equal to cell B7 divided by cell C5. You can put this equation in now if you want, if you're working on the data entry, but then the concentrations will pop up as you populate the cells. So go ahead and enter the equation in now. Let me load up.
But it's the same program. Well, it's just
All right, are we good? I'll go through it again, but are we good? Well, anyway,
I think it's a different one.
we're going to have to make a change to this in just a moment, but I wanted to show you something. The easiest is, do I have to type the formula? Obviously not, right? I don't have to type the formula again, do I? Because I'm just going to copy and paste the formula like this. Just paste it all the way down so it collects it. But there's something weird. Do you see that? What happened? And so when I look at the formula, I click on this, and then I can see what the formula is here. It's, you know, B7 divided by C5, which is correct. But when I go to the next cell, and I click on the formula, it should be B8 divided by C5. And so what happened was it dropped down 1. I don't want C to change, but I want B to change. And so how can I make it so that C, it's not a star, it's a $sign, right? And so what we want is, we don't want 5 to change, so anything you don't want to change, you put a $sign in front of. So it'd be C$5. And then enter. So that formula is wrong, so I fixed the formula here. Now it's C$5. So that 5 never changes because the extinction coefficient is in a fixed cell. If you don't want C to change, you put $1 in front of C and $1 in front of 5. But C is not going to change because we're sticking in this column. But sometimes we put $1 in front of both letter and the letters for the column, the numbers for the row. All right, so when I enter this, I get the same number here, and now when I copy and paste this down, it works here. Now I get numbers here. But you know, I have too many digits here. It's too hard to read, so I'm going to cut it down. Let's cut it down to, let's say, 3 digits or even maybe 4 digits because it doesn't change much. And then we can center this as well. Come on.
Oh, so you put in the cell, and then right before you put in the number, you put $. Yeah. Okay, that was the
Yes. What are we going to use this data for?
The concentration divided by.
The concentration? We're going to make a concentration of CV versus time. Like a, concentration of A versus time plot. So we're going to do. Now, I'll wait for people to get caught up, or should I move on? Huh? Give you time to get caught up? Or just you figure it out yourself with the template? No? All right, give you time to get caught up. How many people are ready to go? All right, if you're ready to go, you know what I'll do? I'll just go through it again for those people who are waiting to get caught up. And so I'll go through it again in a minute, but keep entering your data. And all right, Excel helps in your homework too, because the homework asks to make plots. So if you have a computer, you can just do it quickly. We're going to make 3 plots. We're going to make concentration versus time, and ln of concentration versus time. Yeah, Matthew?
I'm having a little issue here with the formula. I'm not calculating
The formula? You could just, for the ln of concentration, is just equal to ln b the cell. Just pick the cell, C, whatever. We're doing 2 runs, yes. We're going to do run 1 first, and then you're going to do run 2 by yourself. Run 2 is just the same analysis here, which we'll do, and then we're going to work up the data once we do that. All right, so let's continue on here. To do the natural log of the concentration, I just say equals ln, and then just hit the cell. Cells of, yeah, okay, equals ln parentheses C7. And then just close the parentheses. And then enter. So we get the natural log of the concentrations, and then just copy and paste the formula for your data here. All right, and then the final column will be how did I what? Oh, we have 0. No, you have to go back up. There's an error in that, so in that formula. Okay, for C1. All right, the last column is going to be the inverse of the concentration, 1 over the concentration, right? And so here the formula is just going to be equals 1 divided by B7, or C7, sorry, C7. 1 divided by C7. And then just copy and paste that down. We could have done two fewer copying and pasting if we just copied this whole row down. That's okay. Okay, does everybody have the 3 columns of numbers? from the concentration? All right, now we're going to make a plot. When we make a plot, you highlight the X data first. And so we're going to highlight the time. Don't do multiple clicks when you're highlighting data because that will give you multiple lines. I only have 17.2 minutes, so I'm going to stop there. All right, and then what we're going to do is we're going to control click the Y data. And so control click the Y data. All right, so now I have the X data and the Y data highlighted, and I'm going to go to Insert, Scatter, and do the scatter plot without the line, the first option. Okay, here it is, my plot. A little bit too big. Shrink it down. Hey, does that look linear to you? No. No, so it's not looking zero order, but even though it's not looking zero order, we want to plot it out. We want to use it and have the data there. And so what we're going to do is we're going to get rid of the series 1. We only have one series, so just click on that box and delete it. And then we need to put in the data labels. And in other words, we need to put in a title and all that other stuff. And so that would be under layout. You see we have all these tabs across the top here. Click on this one under chart tools here, layout. And then we want to put in the title. What should we call this? All right. So let's do it centered above chart or overlay. All right, above chart. And then you can just type in the command bar here if you want, or in the box itself. Concentration of CB, crystal violet. It's actually crystal violet plus, I guess you can put in there, versus time. The crystal violet ion. All right, then we need to add axis titles. So let's do the horizontal here. This is going to be the time in minutes. And then let's add the vertical axis. I'm going to have mine rotated. And this is going to be absorbance, which are dimensionless. All right, now what we want to do is we just want to show how linear or nonlinear this is. And so what we're going to do is we're going to do what's called a trend line here. You could either click the trend line chart tool or you can right click on the data. If you right click on a data, there's an add trend line option here. You click on that. We're going to fit this to linear. And then I want you to click the bottom two boxes. The bottom two boxes are display equation, display R squared value, and close. Let's move it up here, out of the way. Two things. I don't like 1 sig fig. Do you see I have 1 sig fig in my y equals mx plus b equation? I don't like that. And so I'm going to change the number of sig figs by right-clicking on the box, format trend line label, number. I'm going to use maybe 5. I'm going to use 6 decimal places. Let's see what happens with 6. That looks worse. Yeah. Maybe I'm going to go scientific. Let's go scientific. With 6 decimal places is probably overkill. I'm going to go scientific with 2 decimal places. So go back to format. Oops. want that. Go back to format trend line labels. Scientific, I'm going to go with 3 decimal places. That should be enough. Okay, now that gives me some decent number of sig figs to work with. Hey, if you look at the R squared, an R squared value of 1 means it's a perfect fit. And so a perfect fit would be all the blue data points match perfectly with the black line. Is this a perfect fit? I'm gonna make the line thicker. Is that a perfect fit? That's an awful fit, but look at the R squared. The R squared is 0.949, like 0.95. If you have an R squared of 0.95, is that good? No, it's not good, as you can see by the line, right? And so really, when we're looking for an R squared, and you're going to say it's linear, you're looking for not just 1 9, but at least 3 9s, 2 or 3 or 4 9s, 0.999.
How did you adjust the decimal places on your R squared equation?
Oh, on the R squared equation, you right-click here, format trend line label, and then I changed it to scientific because the numbers are so small. And then just here, you could adjust the number of decimal places here. I put 3 decimal places. Yes.
You put this file on the that you just created.
All right, I'll do that. Oh, right now?
Yeah.
All right. I'm going to call this version 3.
Did you save the last post data on the file? Did you actually redo it? I just copied and pasted it. No.
Oh, I just moved it.
All right, it's up now, version 3. All right, after you guys enter the data, I'm going to go through this one more time, but this is a lot of repetition because after you finish this one, you're going to generate a new plot with ln of the concentration versus time, and then another plot. And so you're going to have 3 plots for run 1, and then 3 plots for run 2.